Marine waves, currents and work, erosion, transportation, deposition and shoreline and landforms. The geomorphic process that operates along the coastal areas is called as marine or shoreline process. The geomorphic agent that operates mostly in the coastal process is the sea waves. The sea waves piles up the water on the coast and the same water goes back into the sea. This process is continuous in nature. Therefore, coastal processes are dynamic in nature. The movement of seawater in the form of sea waves from sea to coast and from coast to the sea produces a distinct landscape along the coast. We would like to know about what are these landforms and how they are formed. How and which parts of the shoreline the sea waves operate. Keeping these aspects in view, the main objectives of this lesson are to understand the characteristic of the sea waves, to know about the various zones of the shore where marine processes operates, to know the nature of the work undertaken by sea waves, to study various depositional landforms produced by the sea waves. Waves and currents. The ocean water is dynamic in nature. The physical properties of the ocean water like temperature, salinity, density and external forces like the sun, moon and the winds influence the movement of the ocean water. The ocean water experiences both horizontal as well as vertical movements. The waves and the ocean currents are the horizontal movements of the ocean water, whereas vertical movement is in the form of tides. Waves. Sea waves are the oscillations on the surface of the water caused by the winds and some other factors. Wind is the most important influencing the waves. The transfer of kinetic energy of the atmosphere, that is wind, to the hydrosphere in the form of waves. Winds provide energy to the waves. Wind causes waves to travel in the ocean and the energy of the waves is released on the shorelines. Sea waves are generated due to the friction on the surface of the water caused by the blowing wind. Most of the waves are caused by the wind driving against the sea water. Characteristics of the waves. Sea waves are defined as the undulation on the sea water, characterized by the well-developed crest and troughs. The characteristic or the environment of the sea waves is described as 1. Wave crest and troughs. The highest and the lowest points of the wave are called as wave crest and wave trough respectively. In other words, the upper part of the wave is called as the crest and the lower part is called as the trough. Wave height. The wave height is the vertical distance between the wave crest and wave trough. The height of the sea waves generated by the wind depends on the wind speed. Wind, when passing over the sea surface, produces friction. When the wind speed is very low, that is less than 2 knots or in the form of a breeze, blows over the calm water of the sea, small ripples are generated and grows as the wind speed increases. The maximum wave height is determined by the strength of the wind or wind speed and the duration of the wind from one direction only. The height of the sea waves is more in case of storm waves and tsunami waves. Wavelength. Wavelength is the horizontal distance between two successive crests or two troughs. Wave frequency. Wave frequency is the number of sea waves passing through a given point per unit of time. The wave frequency varies according to the wavelength of the sea waves. There is an inverse relationship between wavelength and wave frequency. That is, shorter the wavelength, higher the wave frequency, and longer the wavelength, lower the wave frequency. Constructive and destructive waves. From the geomorphological point of view, the sea waves are divided into two types: constructive waves and the destructive waves. Low frequency waves approaching the shore are constructive in nature because they lose volume and energy rapidly while moving up the beach, because water percolates in the shingles and other beach materials, and thus backwash is weakened. It is thus obvious that low frequency waves helps in the deposition and thus help in building the beaches. The high frequency waves with short wavelengths and high wave crest are destructive in character because instead of spilling, they plunge and generate powerful backwash which removes the beach material and transport them towards the sea. Currents. Ocean currents are continuous flow of huge amount of water in definite direction. Water moves ahead of one place to another place through ocean currents. The movement of surface water in the oceans is called as currents. One of the factors responsible for ocean currents to move in a particular direction is the prevailing wind. Currents differ from the waves in that there is a continued and progressive forward movement of the water in currents. Winds are directly or indirectly responsible for the major surface currents. Sea coast and seashore. Generally, sea coast and seashore are taken as synonymous, but geomorphologically these two terms are different meaning. Seashore represents the zone of land between high tide level and the low tide water level, while the shoreline represents the actual landward limit of the sea water at a given point of time. The shoreline fluctuates from time to time and is influenced by waves and tides. Shoreline is dynamic in nature. Shoreline represents the shifting line of contact between sea water and the land. The landward limit of the sea is called as shoreline. The coast represents the cliff line or the margin of the land rising above the sea level. It is the boundary between the land and water or the seaward limit of the land. Here two terms are used, more or less meaning the same. Division of the shore. The shore is divided into three zones. The shoreline or the marine process operates within these zones. Backshore. Backshore represents the beach zone starting from the limit of high tide level to the sea cliff base, or the zone that extends between the base of the sea cliff up to the limit of high tide level. Foreshore. Foreshore is a zone that extends from the high tide level to low tide level. Offshore zone. Offshore zone represents the zone of shallow water extending between the low tide level and beyond it, that is the continental shelf. Nature of sea waves. The sea water which is carried by the sea waves towards the coast and back into the sea is termed by various names as breaker, swash, backwash or undertow, littoral or longshore current. The work of the sea waves depends on the nature of movements of the water associated with the sea waves, which is as under. Breaker. The approaching sea wave towards the shore is called as breaker. When the sea wave approaches the shore, the wavelength decreases and the wave height increases to such an extent that the crest of the wave topples over. Swash. The uprush of the water towards the shore is called as swash or surf. Piling of sea water against the coast is called as plunge. The distance from the shore where the waves break is called as plunge line. The breaking of the sea waves at the plunge line produces an uprush or swash. Backwash. Backwash is the returning sea current. The sea water after reaching the shore or sloping beach returns back into the sea. The breaking of waves at the plunge line produces an uprush followed by the return flow of the water called as backwash. The water which is carried landward by the sea wave returns seaward mainly by a bottom flow called as undertow. Littoral or longshore current. Longshore currents are generated when the waves break obliquely against the shore. Work of the sea waves. Like other geomorphic agents, the sea wave also undertakes three types of work: erosion, transportation and deposition. Mechanism of marine erosion. Sea waves undertake erosion of the coastal lands and backshore through the processes and the mechanism of 1. Hydraulic action, 2. Corrosion or aberration, 3. Corrosion or solution. Hydraulic action. Hydraulic action refers to the impact of moving water on the coastal rocks. Repeated striking against the coast by the sea waves enlarge the existing joints and fracture and thus helps in breaking the rock into smaller pieces. The sea waves are capable of dislodging these rock fragments. The process of removing the rock fragments is called as quarrying and plucking. Wave quarrying and wave plucking are caused by the hydraulic pressure, is very effective mechanism of erosion. The striking breaking waves also exerts enormous pressure on the air trapped in the crevices and hollows within the coastal rocks. When the waves strike the rocks as swash, it leads to the process of compression, and when the waves return back, wash it leads to the decompression. The alternate process of compression and decompression causes pressure changes and weakens the rocks and the cracks becomes enlarged and breaks into blocks. Aberration or corrosion. Aberration is caused due to repeated forward and backward movement of the sand, gravel and pebbles which are hurled against the rocks on the coast. The collectiveness of the aberration or the effectiveness of the aberration depends upon the presence of erosive tools like sand and gravel carried by the sea waves and the frequency of sea waves. Attrition involves mechanical wear and tear and consequent breakdown due to mutual collision affected by backwash and rip currents. Corrosion or solution. It is the solvent action of the chemical alteration of the rocks by the seawater. It is important in case of limestone rocks or carbonate rocks. Transportation work by the sea waves. The eroded material transported by the sea waves varies significantly from other agents of erosion and transportation. The currents moving from the coast and the beach like backwash or undertow currents pick up the eroded material and transport them seaward, but the rushing currents like breaker waves or surf currents pick up these material and bring them again to the coast and beaches. The transportation work of the sea waves involves the transportation of material from the coast towards the sea and from sea towards the coast. When the oblique waves strike the coast, longshore currents are generated. These longshore currents transport the material parallel to the shoreline. The materials involved in the transportation by the sea waves include sand, silt, gravel, pebbles and cobbles, etc. Deposition. Sediments transported along the shore is deposited in areas of low wave energy and produces a variety of landforms. Different types of sediments are deposited along the shoreline. The deposited materials include unconsolidated materials like sand, silt, shingles, etc. Shoreline landforms or marine landforms. Most of the activity of the sea waves is confined to the narrow coastal zone, and it is here that sea waves produces distinctive landforms called as shoreline or marine or coastal landforms. Marine landforms are produced by the joint action of sea waves and currents and tides on the coastline. Among these, the most common are sea waves which are generated by the wind. There are two types of factors which determine the type of landforms produced in the coastal areas. The first set of factors are related to the sea waves such as size, shape, frequency, height of the sea waves approaching the coast. The other factor is related to the characteristic of the coast like structure of the rock, configuration of the coastline, etc. It is the erosional and the depositional work of the sea waves that leads to the formation of marine landforms. The marine landforms are classified into two types: one, depositional landforms, and two, erosional landforms. Depositional landforms. The depositional landforms produced by sea waves are broadly classified as beaches, bars and associated features. One, the beaches. Beaches are the characteristic of the shorelines that are dominated by deposition. Temporary or short-lived deposits of marine sediments consisting of sand, shingles, cobbles, etc. on the seashore are called as beaches. Beaches are the depositional feature in the zone extending between high and low tide water level. Beaches are generally formed when the sea is calm and winds are of low velocity. Beaches are temporary features. The sandy beaches may be reduced to a very narrow strip of coarse pebbles. There are various types of beaches such as bay head beaches. The sandy beaches formed at the head of the bays are known as bay head beach. Emerald Bay of the California is called as Bay Head Beach. Pocket beach. The beaches formed at the head of the small indentation at the coast are known as pocket beaches. Shingle beaches. The coast which are made of layer of pebbles and cobbles are known as shingle beaches. For example, the Thrum Cap in Nova Scotia has many shingle beaches. A shingle beach is composed of flat, circular, smooth stones. Pink beaches. The beaches formed along the shoreline which are made up of corals and shells of marine organisms is called as pink beaches. Pink beaches are common in Bermudas. Bars, barriers and associate features. Bars and barriers are the deposition made by the sea waves along the coast. The ridges formed by the deposition of the sea waves parallel to the shorelines are called as bars. The larger forms of bars are called as barriers. The bars are submerged under the sea at the time of high tide, while barriers do not submerge. Bars and barriers may be formed near the coast or away from the coast, parallel to the coastline, or the transverse to the coast. There are different forms of sandbars and associated features such as longshore or offshore bars, 2 spit, 3 hook, 4 loop, 5 winged headland, 6 connecting bar, 7 tombolo, 8 barrier islands. Longshore or offshore bars. The sandy bars are formed in such a way that they are parallel to the coast but are not attached to the land. They are called as offshore or longshore bars. A ridge of sand and shingles formed in the sea in the offshore zone, that is from the position of low tide waterline to seaward, lying approximately parallel to the coast, is called as offshore bar. When the offshore bars are long and continuous, they form barrier beaches. Spit. If the sandbars are formed in such a way that their one end is attached to the land while the other end projects into the open out towards the sea, they are called as spits. Spit may also develop and get attached to the headlands. Spit are formed by the deposition of sediments moved by the longshore drift. Spit formation is mostly seen along the eastern coast of India. A well-developed spit is formed to the east of Kakinada Bay along the Andhra Pradesh coast. Hook. High energy storm waves very often modify the shape of the spit by bending or curving them towards the coast. The curved spits assume the shape of a hook and thus spits are called as hooked spits or simply hooks. Such spits whose seaward end is bent or turned towards the land is called as hook. Thus, a hook develops from the landward bending of the spit. Sandy Hook of New Jersey of USA is a well-known example of hook. Loop. When the opposing currents become more dominant than the littoral currents, the sandy bar or the spit is bent in such a way that the other end is also attached to the mainland or the coast. Thus, it forms a complete loop which encloses the sea water in the form of a lagoon. Winged headland. When the bars or elongated deposits of sand, pebbles and cobbles are formed on the either side of the headland, such headlands is called as winged headland. The deposits on the either side of the headland forms the bar resembling two wings. Connecting bar. Connecting bars are formed when bars are so extended that they either join the headlands or two islands. The island connected with the coast by a bar is called as tide island. Tombolo. Connecting bars are variously named on the basis of their shape and form. The bar connecting two headlands or two islands or island with the mainland or the island with headland is called as tombolo. Barrier islands. Barrier islands are the offshore islands of sediments tending parallel to the shore. They are the islands near the coast but are not connected with the mainland. They are separated from the mainland by a lagoon. Many of the barrier islands are cut by one or more tidal inlets. Barrier beaches. Barrier beaches are not submerged by the tide. Barrier islands includes the Lido of Venice and Frisland Islands of Denmark. Conclusion. The landscape that is produced along the coast by the sea waves is called as marine or shoreline landforms. Sea waves and currents are the horizontal movement of the water. Sea waves are generated due to the friction on the surface of the water caused by the wind. The work of the sea waves includes erosion, transportation and deposition. The marine landforms are either produced by deposition or erosional process. The depositional features includes various types of beaches and the bars. The features associated with the bars are offshore bars, spit, hook, tombolo, etc. In the next session, we will be discussing about the erosional landforms and other aspects related to shorelines.